Okay guys, we have calculated the meter surface area. So now we have to calculate now the meter surface area that we calculated is around 206.05 meter cube, right? So meter square. So we have to take this in feet square. So by multiplying with a constant multiplication factor, WS is equal to 206.05 into 10.97635. So if you multiply with this constant you will get out in feet square. It is approximately 2218 feet square. So because the units, you have to concentrate on the units. Mostly if you follow the units perfectly, then only you will get all the data perfectly. So just take this value in feet square. Just note this down. 2218 feet square. So to calculate first we have to calculate this vapor load. Q equal to F into A power 0.82. So we know this value and we have to calculate the environmental factor. So that was given in API book. For designated values, we have some constant values, or we can calculate by using the formula I already given. That is F environmental equal to 0.01319 into the multiply with the thermal conductivity of the insulation plus 0.00302. So you can use this formula, or otherwise you can use the table that was given in API book. So based on this table also you can get the value directly. So by using this one, I have calculated. So as per our insulation thermal conductivity is given here is capital K value is 2.9. So as per this value you are getting around 0.035 approximately. So this K value we have calculated 0.039, approximately 0.04. So we know this F value and vector surface area, and we can take the vapor load. We can calculate this one. Q is equal to 21,000. So this 21,000 is for if we have the firefighting. If we don't have, if we have the firefighting facilities and additional safety system and all on training facilities. So in this case, we are taking it as the most risky case, worst case. So it doesn't. We can consider it is not having any firefighting or it is having any firefighting facilities or not. So we just write this down. It is having adequate drainage system with firefighting facilities. So mostly firefighting facilities. So we have firefighting facilities and everything. So if you don't have that one, what will be the constant? The constant will change to 34,500. So into FA power 0.82. So by using this formula, you can calculate this vapor load. So all the factors we have to consider before calculating the area of PSV or size of the PSV. So everything will be given. That will be selected based on the conditions and parameter or site parameters, based on the process conditions. These things will be selected as per APA standards that is given. We calculate this one as per this formula. The Q will be around 465,551 BTU per hour. So here we are applying the value area in feet square. So that is, we have calculated this one. And environmental factor, that is here. So it was taken watt per meter degree Kelvin. So you can take this data directly in from the API table, or we can apply this formula and find out if it is having not exact value. So we got this Q value. This is total heat of absorption. So we know the total heat of absorption now. Let's take this value here. is equal to 46551 BTU per hour. Okay. So now we found out the Q. Why we are finding this one? To find out the W, which is total vapor load. Vapor load is equal to Q by lambda. So lambda that is required here is the given data given here is 160. We can take kilojoule per kilogram approximately. So that the data whatever I am taking is the random data. So you don't need to go for the exact one. We can take an example, another example scenario and calculate it. Just for the calculation purpose only I am taking all this data. So calculate this one 46551 divided by lambda is 160 kilogram. So the value will be around but here the value we have is kilojoule per kilogram. We have to take this one into, because this is in BTU per hour. So we need to equalize the units. So for this we can take this 160 kilojoule in pounds. So that will be equal. So this will be around 68.786 BTU per pound. Right? So this value you can apply here. So if you apply this same value 68.761, we have to equalize the unit. So that's why I have taken this value. So 68.786. So the value will be around 6767. Be careful with the units. If you change the units, all the calculation will be getting wrong maybe. So we have to follow the units exactly. So the value will be around 67.6795. So BTU per hour, BTU can cancel. So we are having in pounds. So we have the vapor load. We got like 67.6795. So this is the value vapor load. So we got that vapor load right now, and we have to take the data of for finding the RFI size. So this we can take this mention here 67.95 is equal to W 6767.95 pounds per hour. So now we have all the data, and one more thing is that I'll give you a few given data. I didn't mention now. If we need, we can mention, no problem. So the other data that we need is, now we know the Q, F, A, W, everything. So to find out this AKL, this is mentioned as AKL. There is orifice size, orifice area, that is equal to, we have a formula like W divided by C into D1 into KD into KB into KC multiplied with the square root of T is divided by molecular weight. So this is the formula for finding the RFI size, and further we can find out PCFR and PCF. If you want, you can find this one, or otherwise we can leave it. So that is different one, we can see that later. So finding C, we have a formula. We know the W value. Finding C is equal to 520 square root of K into, this is the ratio of specific hits divided by K plus 1 whole power of K plus 1 divided by K minus 1. This is a formula for finding the C value. And when you go for KD is mostly it will be as per the recommendation. We are taking this PSP. So we have PSP. When we have PSP, we can take this KD value. This is effective discharge coefficient. You can take it as 0.975. This is a constant taken from API 52026. So, and if you don't have PSV, you are having the safety relief of with a different kind. So you will go for another value of 0.62. So we are not going this right. We are going as 0.965 because we are installing PSV. And the next one is KB. This is this capacity correction factor, that will be taken as 1 because this PSV is of conventional type. So if it is conventional type or pilot operated type, you can take this constant as 1. If it is other thing, then the value will change. The next thing is, so we know the KB and KC we have to know. KC is combination correction factor. So that is depends on PSV. If we have PSV, that is depends on the rupture disk. So here we are not going for rupture disk. So if we don't have rupture disk, the value will be 1.0. If we have rupture disk, it will be 0.9. So because of the restriction of the rupture disk. So we know KC, KD, KB, and now we have to calculate the P1. We can take this C value from this formula. I already calculated this one. Based on that,